Hello everyone. So today we are going to start our new topic of classical mechanics. So what is this our syllabus for classical mechanics? First of all, we will discuss about Newton's law of motion. Then we will go for phase space dynamics. Then we will dive towards stability analysis, central force motion, and Kepler's law, three laws, gravitational field, and potentials. Two-body collisions, scattering in laboratory, center of mass frames, CM, 8 body dynamics, angular momentum, moment of inertia, टेंसर नॉन नेचुरल फॉर्म शूडो फोर्सेस वेरिएशनल प्रिंसिपल. देखो ये यहाँ से फ्रॉम हियर टू हियर इट इज एमएससी पार्ट. ओके टिल फ्रॉम नाउ फ्रॉम हियर टू हियर इट इज योर 12th प्लस बीएससी पार्ट. फ्रॉम नाउ ऑनवर्ड्स इट इज एमएससी पार्ट. Lagrangian Hamiltonian formalism and equation of motions, Poisson bracket, canonical transformation, symmetry, invariance, conservation laws, cyclic coordinates, periodic motion, small oscillations, normal modes, damped harmonic oscillations, DSHO. Driven harmonic oscillation, waves in media, supershock waves, STR, Milton transformation, electricity kinematics and mass energy equivalence, kinematics of moving fluids, Bernoulli theorem, viscosity and surface tension. So you can say that whole mechanics is there for you, nothing left. You have to study the whole mechanics of physics. So classical mechanics, first of all we will go for Newton's law. You mention Newton's law. First is particle. A particle is ideally just a piece or quantity of matter having practically no linear dimension but only a position. तो पार्टिकल क्या है? ओनली पोजिशन को रिप्रेजेंट करता है, ओनली पोजिशन को. इसकी कोई डायमेंशन नहीं होती, लिनियर डायमेंशन नहीं, इसका कोई लिनियर डायमेंशन ही नहीं, बट ओनली ए पोजिशन. The measure of this quantity of matter being the mass of the particle. So इस क्वांटिटी का मेजरमेंट क्या है? मास है. ऑब्जर्वर क्या होता है? ए पर्सन और इक्विपमेंट विच कैन लोकेट, रिकॉर्ड एंड मेजर. एन इवेंट इज कॉल्ड एन ऑब्जर्वर. इवेंट क्या होती है? An event is turned in our mathematical model for anything that occurs suddenly or instantaneously at a point in a space. Rest. So a particle is said to be in rest with respect to a frame of reference. If particle is not changing, does not changing its position, then particle is said to be in rest. And if particle is changing its position with respect to frame of reference and with respect to time, then it is said to be in motion. Now, Aristotle, a philosopher, named Aristotle, according to him, constant force has to be applied on a body to keep in motion with constant velocity. But Galileo, 1564-1642, according to him, no force is required for a body to move with constant velocity. This was the basic contradiction between Galileo and Aristotle. Now Newton. First law: a body must continue in its state of rest or in its state of uniform motion along a straight line unless and until an external force does not apply to it. Second law is F equal to dp by dt, which shows that rate of change of momentum is proportional to the impressed force and takes place in the direction of force. Third is acceleration law. F12 equal to minus F21. Every action has an equal and opposite reaction. Second law is known as real law of motion. Okay. First law of motion is simply a special case of second law. क्यों होता है ऐसा? F equal to m है. If f is not 0 then a equal to 0, then particle must be moving with constant velocity or velocity will be 0, uniform velocity. So physical meaning of this is, if a particle is moving with constant velocity, if you want to move a particle with constant velocity, then you have to apply no force on it. Okay, you don't have to apply any force on it to move the particle with a constant velocity. From in which condition this condition lies? In space, in perfectly space vacuum. If a particle is moving with constant velocity, there is no need to apply a constant force on it, external force. If it's moving with a constant velocity, then it will remain moving with constant velocity unless and until another force is not applied in the opposite direction. Limitations. So it's not good for where m is changing, dm by dt. Falling raindrop, rocket, particles with electric velocity. Third law of motion implies that the forces entered by two interacting bodies are equal and opposite, provided that both the forces are measured simultaneously. The center of mass gives us the definite future path of a particle if we know the current location and velocity of particle. That's why it is known as deterministic physics mechanics. So classical mechanics giving us the definite future path. So classical mechanics is definite future path. It predicts the future of a particle. And how to predict? If we have the current location and velocity, then we can predict the future. So it is known as deterministic physics mechanics. ठीक है. Based on how to determine the position and velocity of classical particle at any time t, we have three different formulations: Newtonian, Lagrangian and Hamiltonian. Now first, Newtonian mechanics. All the Newton's laws, very basic laws of nature. Let us discuss different types of force which exist in classical system. First is weight. Weight क्या होता है? W equal to mg. M is constant, conservation of mass, but W variable is changing. Newton kilogram into meter per second square, which is Newton. Normal force. Now normal reaction is a constant force acts on a body if its motion is constant in a particular direction. So if this body is want to move in this direction and we have some certain constant here, so it not will be move in this direction, then perpendicular to this direction is opposite to the direction in which motion of body is constant. So motion of body is constant in this direction, so in this direction it will be normal force. Suppose this particle want to fall in this direction, it is not able to fall in this direction, so the direction of normal force will be opposite to the constant side. Acts in the direction in opposite to the direction in which motion remains to continue. The magnitude of normal direction depends on the degree of motion which of the body is constant. Now we have three questions here. Suppose this is freely flying body. So it will fall with acceleration g in negative acceleration, negative. So if we take this formulation, it's negative g. So there is no constraint, it will freely fall from above. So no reactive force will be there. So normal force will be 0. Suppose we have 10 kilogram mass here and particle is at stationary state. So there will be no movement of the particle. So what will happen? Normal force, particle want to move in the direction, but this is the constraint. So normal force will be opposite to the constraint in the direction. So what will happen? N minus 10g equal to 0. A is 0 here, no acceleration here, n equal to 10g. Look at this condition, particle mass want to move in the box, want to move in this direction. So what will happen? Constraint will be in opposite direction, normal force will be in opposite direction. So 10g minus n equal to ma, summation of f equal to ma, m into a 2. What is happening here? 10g here, this box want to move in opposite m direction and particle want to fall. So normal force in opposite to the constraint. So n will be equal. So n minus 10g equal to 2 into m. Okay. Now look at this. Normal reaction निकालना है हमको and whole is going downwards. So suppose we have consider this whole as a system. So it's 15 kilogram. 15 kilogram want to go down, but this constant horizontal surface is restricting it to go down. So what we have, normal direction opposite to constant will be in this direction, but overall system is moving in downward. So what will happen? 15g minus n equal to 15 into 2. So n will be up to one more. Can we think we can do? We can make Fibonacci diagram. So first of all, make Fibonacci diagram of this part, 5 kilogram. So we have taken 5 kilogram here. So what will happen? 5g will be in downwards. Now 5g will be downwards, and so the whole mass is want to go in downwards, but we are restricting it from going downwards. So what will happen? Constraint in n. Okay. So what will happen? 5g minus n equal to 5 into t. Acceleration will be same. Why acceleration will be same? Because those two boxes are going down with one another, not separately but combinedly. Okay, so we are getting 40 Newton here. Now again make Fibonacci diagram 10 kilogram. So just take 10 kilogram here. So just take 10 kilogram here. So 10 will be downwards. Okay, and particle want to go downwards, so reactive force will be upwards. But on this 10g, this force will also applied something on 10g. Why it is so? Because this want to go upwards, this want to go downwards. So 10g minus 10g plus n minus r equal to m into 2, and you will get same answer. Get my point or not? Got my point or not? Okay, 10g plus 10g plus n minus r equal to 2 into 10. Hope you got it. Okay, so just make Fibonacci diagram of this. First 5 kilogram and then 10 kilogram. 5 kilogram is this. So want to go downwards, constant is on down, so it will go on up. Here also constant is down, so reactive force will be up, but n is above. So just we have make figure diagrams of these two and solve these questions. Okay, here also what we will do, we will make figure diagrams. So just in the case for 2 kg. Okay, so what will happen for 2 kg? 2 kg want to move, go downwards. 2 kg want to go downwards, so will be force over upwards n2, but there is no force for 2 kg in this direction. Okay, what will happen? What, let's take 4 kg. Okay, for an instant. So what is happening on 4 kg? 4 kg 20 newton is on this direction. Okay, and 4g is on downwards, so reactive force will be upwards. But 4 kg wants to go here, but 2 kg is not allowing us to go this direction, it is constant, so reactive force will be in opposite direction r, and same r will be applied to here. So let's make equations. 4g minus n1 equal to 0, so n1 equal to 14 newton, and 20 minus r equal to m into a. 20 minus r equal to a, we have calculated the r here, equal to 4 into a. So here will be this, and for 2 kgs here only r is applied, reactive force. So n2 equal to 2g and r equal to 2 into a.